Okay, I want to talk about derivatives for a second. So if we have this line here and we were to graph it, it would look something like this, right? And then if we wanted to find the slope of the line, well, then we would have to get 2 points like this and this. So this would be like x1, y1. This would be x2, y2. And then we can use this formula here. But what if we have a function like this? Well, if we were to graph it, then it would look like this. And you see, this formula here wouldn't make any sense because it's not a straight line. So if we took like, for example, this point here and this point here, we would get that slope. And if we took this point here and this point here, we would get a different slope. See, we could take a few different points like x is equal to 1 and then get this point here, and then x is equal to 0 and get that point there, and then x is equal to -1 and then get this point here. And then at each of those points, then we would have a different tangent line, right? So we'd have that tangent line there, this tangent line there. And what we need to do is get the slope of each of those tangent lines. That's where the derivative comes in. So if we take the derivative, dy dx is equal to 2x, then what we can do is we can say, take this 1 and sub it in here and get dy dx is equal to 2, and then take this 0 and sub it in and get dy dx is equal to 0, and then sub in this -1 and get dy dx is equal to -2x. And so you see this here is the slope of this line, and then this here is the slope of this line here, and this here is the slope of this line here. So that's why we take the derivative.